Good morning, children. So in last class, we discussed about properties of alpha, beta, and gamma. What are alpha, beta, and gamma? Alpha, beta, gamma are nothing but is the harmful radiation it emitted in the process of radioactivity. So radioactivity நடக்கும்போது இந்த process alpha, beta, gamma emit ஆகிற process நடந்துட்டு இருக்கு. Okay, so அதோட properties தான் we discussed in our last class. And today we'll discuss about radioactive displacement law. So after the properties of alpha, beta, gamma, today we'll discuss about radioactive displacement law. So in the year of 1913, Soddy and Fagen they framed displacement laws governing the daughter nucleus produced during an alpha beta decay. So என்ன nucleus produce ஆகுது, daughter nucleus is produced, and that is stated here. First point, when radioactive element emits alpha particle, okay, when the radioactive element emits the alpha particle, a daughter nucleus is formed. The mass number is less than 4 units and atomic number less by 2 units. So mass number என்ன ஆகுது, 4 units less ஆகுது, atomic number is reduced by 2 units. Then mass number and atomic number of the, from the mass number and atomic number of the parent nuclei. This is the emission of alpha rays. And next point, when radioactive element emits the beta particle. So we know what is beta particle. Beta particles are nothing but the electrons. While emitting the beta particles, the mass number remains same. Mass number இங்கே வரும், டாப்ல வரும்ல. Okay, for example, we are writing the formula 8O16 எடுத்துக்கோங்க. Okay, so இதில் reduce ஆகிறது வந்து we can say mass number, and this is what the atomic number is more by unit. The atomic number is more by unit. This is atomic number. If it is increases by 9 and mass number remains same, it is emission of beta rays. For example, I told. Okay, and mass number, atomic number you may discussed in chemistry. And if it emits same mass number and increases by 1 atomic number, means it is forming, it is producing the beta rays from the parent nucleus. Okay, this is called as what? It was explained by Soddy radioactive displacement law, which was explained by Soddy and Fagen in the year of 1913. Next is, it is about alpha decay. So how the alpha decay will happen here, we'll discuss here in this topic 6.2.3. A nuclear reaction in which an unstable parent nucleus, the parent nucleus should be unstable. Stable தெரியும்ல, it will be in rest. Unstable என்றப்போ it is in excited. So how the parent nucleus is? It is unstable. It emits the alpha particles, and after that it forms the stable daughter nucleus. So who is emitting the alpha? Parent nucleus. That parent nucleus is unstable. So emit பண்ணிட்டு என்னவா மாறுது? It will become a stable daughter nucleus. It is producing stable daughter nucleus. It is called as alpha decay. What is this? This is called as alpha decay. And here example is given, the decay of uranium U-238 converting into thorium Th234 with the emission of an alpha particle. Okay, and see here, this 92 U-238 uranium is parent nucleus. This parent nucleus is in unstable state. So this U-238 emitting losing the 4 mass number, and atomic number is reduced by 2. So mass number எவ்வளோ reduce ஆகுது? 4 reduce ஆகுது. Atomic number is reduces by 2. Then it emitting the helium after convert the uranium into thorium. So uranium thorium convert ஆகுது after emitting the helium, and this decay is called as alpha decay. So what type of decay this one? This is called as alpha decay. And in alpha decay, the parent nucleus here is uranium, which emits the alpha particle. So it's clear the daughter nucleus is here thorium. The mass number and atomic number decreases by 4 and 2 respectively. So it is illustrated in the figure 6.1, and check this figure. This is uranium, which is called as parent nucleus. It losing the helium. Helium is nothing but what? Positive charged alpha particle. After losing this helium, the rest part is 90 TH 234. இங்க பாருங்க, அட்டாமிக் நம்பரில் 92 இருந்து என்னாச்சு, 90 மாறிடுச்சு. 238 இருந்து என்னாச்சு, 234 ஆச்சு. எவ்வளோ ரெடியூஸ் ஆயிருக்கு? மாஸ் நம்பர் 4, அட்டாமிக் நம்பர் 2, அதுதான் இங்கே கன்வெர்ட் ஆயிருக்கு as helium. This decay is called as alpha decay. So what decay this one? This is called as alpha decay. Have you understood, children? Yes, good. And now we will discuss about beta decay. This beta decay, in this also we need parent nucleus that is unstable. After emitting the beta, it forms daughter nucleus. This decay is called as what? Beta decay. And now you see the formula. The phosphorus 32 is what? Unstable parent nucleus, and it's converting to sulfur after emitting the beta. So how the beta in the formula எல்லாம் பாருங்க. This is atomic number 15 என்னாச்சு, it gains 1. See mass number, it is same என்றப்போ it is 0, it is minus 1. So this gaining, it is because of removal of electron, that means beta. This resultant is called as beta decay. So after emitting the electron, the unstable parent nucleus will become a stable daughter nucleus. Here it is sulfur. This is what? This is called as beta decay. Okay, and in beta decay there is no change in the mass of the daughter nucleus, but the atomic number is increases by 1. Here we have to note one thing. In nuclear reaction, the element formed as a product nucleus is identified by atomic number of the resulting nucleus and not by its mass number. So what we will keep in our mind? We will keep in our mind the atomic number only, not a mass number. Have you understood, children? Yes, good. Next one, the last decay is gamma decay. So in a gamma decay, there is no change in mass number and atomic number. The mass number and atomic number is remain same. This gamma decay will may comes from alpha or beta. So alpha illa beta நடந்ததுக்கு அப்புறம் இந்த gamma decay நடக்க சான்ஸ் இருக்கு. In this gamma decay, only the energy level of the nucleus will be changed, and atomic number and mass number remains same, and this effect is called as gamma decay. Have you understood, children? Gamma decay எது மட்டும் சேஞ்ச் ஆகும்? Only energy level alone changing. There is no change in atomic or mass number of the radioactive nucleus. That too will be remain same. That is called as gamma decay. Okay, so we understood. So when alpha is emitted, the forming daughter nucleus is called as, this decay is called as alpha decay. Then beta is emitted, daughter nucleus is forming after the beta decay. And for gamma decay, there is no change in atomic or mass number. It is only the difference between the two energy levels. That is only producing this gamma decay. Okay, and in first two, in all these three, we need unstable parent nucleus. The unstable parent nucleus which is emitting the stable daughter nucleus. That is more clear in this. Then only the alpha, beta and gamma decay will occur. Okay, and next we'll enter into the nuclear fission. And here we'll see about nuclear fission. And about this nuclear fission, in the year of 1939, the German scientist Otto Hahn and Strassmann, they discovered when the uranium nucleus is bombarded with a neutron or The uranium nucleus is collided with the neutron. This uranium nucleus is breaks up into smaller nuclei of comparable mass. Uranium is huge nucleus. We are breaking that nucleus with the help of neutron in the process of collide. So we are mating them. So comparable mass along with the emission of few neutrons and energy. ஸோ இது கொலைட் ஆகும்போது என்ன ஆகுது, யுரேனியம் நியூக்ளியஸ் வந்து பிரேக் ஆகுது. பிரேக் ஆகிட்டு ஹியூஜ் நியூக்ளியஸ் என்ன மாறுது, ஸ்மால் நியூக்ளியஸாக மாறிடுது. அலாங் வித் தட் சம் நியூட்ரான்ஸ் ஆர் எமிட்டட் with some energy. This process of splitting of a heavier nucleus into smaller nuclei with the release of large amount of energy with few neutrons is called as nuclear fission. So nuclear fission என்ன பண்ணுறோம், ஒரு ஹியூஜ் நியூக்ளியஸை நம்ம ஈக்குவல் ரெண்டு நியூக்ளியை நம்ம டிவைட் பண்ணுறோம். So while dividing that, என்னெல்லாம் இதில் ரிலீஸ் ஆகுது, few neutrons, okay, and some energy also released there. This process is called as nuclear fission process. What is that process? This process is called as nuclear fission process. And here the example is given. Uranium is given here. It is bombarded. எப்படின்னா யுரேனியத்தை ஒரு ஃபிக்ஸ்டு பொசிஷனை வச்சுக்கிட்டு அதை டார்கெட்டாக வச்சு we can send more fast moving neutrons. Neutron ஸ்பீடை மூவ் பண்ண வச்சு then we can made to bombard or collide to each other. After collide with the uranium, this is parent is converted into data. Now it is converted into as barium 56141, then krypton 3692 plus 3 neutrons 0 and 1 along with some energy. So during this process, in each fission, it carried about the temperature of 3.2 × 10⁻11 joule. It is the releasing the energy of 3.2 × 10⁻11 joule. So nuclear fission is explained in this picture, figure 2.6.2, very clearly. See the nucleus of uranium. This is neutron. It is bombarded with the uranium. Now few neutrons are emitted along with the two daughter. One is barium, the next one is krypton. So from this nuclear fission process, we can understood how the process will happens here. Okay, so நம்ம என்ன பண்ணுறோம், நியூட்ரானை பம்பார்ட் பண்ண வச்சு ஹியூஜ் நியூக்ளியஸை நம்ம ஸ்மால் நியூக்ளியஸாக ஈக்குவல் பார்ட்ஸாக ஸ்ப்ளிட் பண்ணி பண்ணுறோம். திஸ் ப்ராசஸ் கால்ஸ் நியூக்ளியர் ஃபிஷன். இப்படி ஸ்ப்ளிட் பண்ணும்போது நியூக்ளியஸ் மட்டும் ஸ்ப்ளிட் ஆகிறதில்ல, few neutrons are coming out along with some energy. It's coming out with along with some energy, and this process is what? This process is called as nuclear fission process. Okay, so this nuclear fission process is explained. இதோட இன்னொரு pair பார்த்தா nuclear fusion, and about that we'll discuss in next class. And in this we can't use all the materials. Sharia. So few materials only we can use here, which having the huge mass of the nucleus. Then only we can use for this process of nuclear fission. So today we understood how the radioactive displacement law happens of the Sardinian-Fajon explanation. They explained clearly about alpha, beta and gamma decay. So following that we discussed about nuclear fission. So how important is this and where all we are using, about that we will discuss in upcoming classes. Thank you children.